So we're trying to predict how many hours June is going to sleep, which essentially means how many hours I am going to sleep. So far, we've collected data for 6 days. These are 6 nights of June's sleeping pattern. We then plotted that data. We then calculated the mean, which turned out to be 6. This blue line here represents the average or the mean line. And then we also drew a trend line, which we think will fit this data better. We found the equation for this fit line, which is 0.5x plus 4. And now our task is to predict what these two different lines, or to use these two different lines to predict how many hours June is going to sleep on day 7. So for the first blue line, we know that, well, it's 6. It's always 6. And we can go ahead and write an equation for this blue line. I'll call it B. So B for any I is going to equal 6. And for the red line, this point here, so this point equals 6. And this point here, we need to use our equation to calculate. So first I'm going to rewrite this using the variables at hand. So I'm going to write it, let's call it R. So this red line, I'm going to make the equation R of I equals 0.5 times I instead of X plus 4. This way it's consistent with our other data and equations. And then to calculate how many hours June would sleep on day 7, we simply plug in 7 here. So that's going to be R of 7 equals 0.5 times 7 plus 4. 3.5 plus 4, 7.5. So that's our prediction using the red line. So now our question is, which is better? Which prediction is better? And what I'm going to argue is that we can look at these two lines, the blue line and the red line, and see which one predicted the past more accurately. And whichever one more correctly predicted the past, I'll say will also predict the future more accurately. And to do this, we're going to use the same method that we used when deriving variance. We're going to calculate the distance that we have to travel to go from our line to each of these points. So for the blue line, we're going to calculate this distance, add it to this distance, add up all these distances from the blue line to the point, and then the sum of these distances will be our score, as we call it, for the blue line. And the lower the score, the better. We're using golf scoring. For the red line, similarly, we're going to find this point here, measure the distance to the measured value, and we'll take the sum of all these distances traveled, and then that will be our score for the red line. So to do this, first, to be robust, I'm going to write out the values for our equation for B and our equation for R. So for B of I, we always equal 6, so these will all be 6's. For the red line, R of I. And also do note, so I'm doing B with parentheses around the I, which you'll notice is a little bit different from H subscript I. There's no equation for H. These are just measured values. So it wouldn't make sense to put this in parentheses. This is not an equation. For B and for R, these are equations. So it does make sense to put the parentheses around the I here. So to calculate R of 1, that's going to be this point here. This is R1. We simply plug I equals 1 into our equation. So we can see that it'd be 0.5 times 1 is 0.5 plus 4. So this would be 4.5. Plug in 2, etc. And I'll do these very quickly. And so this first point corresponds to this point on the red line. And then this value is 5. This value is supposed to be 5.5, etc. So the next step is to calculate the distance from the point to each of these lines. And now this actually has a special name. Let me get rid of this for now. And you'll see this called different things in mathematics. When we were calculating the definition of variance, we use the term deviation. But you will also see this distance called the residual. And also sometimes you'll see it called the error. So these all have precise definitions. I encourage you to Wikipedia them if you're curious. For our purposes, these all mean the same thing. And I'm actually just going to use the term error for the rest of this video. So let's calculate the error, which is the distance from the blue line to the dot, or the distance from the red line to the dot. And similarly with the derivation of variance, first I'm going to just calculate the the distance with direction. So that's going to be the point h of I to b of I. For red, it will be h of I minus r I. And so h I is 6, b of 1 is, h of I is equal to 5, b of I is equal to 6, which is minus 1, and for red, hi is 5, h1 is 5, r1 is 4.5, this is 0.5, and I'll pause and do these. So here's the rest of these values. And this is the distance with direction, which doesn't really help us because if a point is below the blue line like this, it's essentially going to cancel the distance of a point that's above the blue line like this one. So what we want to do now is, instead of the raw error, we're going to take the absolute error. Which is defined mathematically as absolute value of h sub I minus b of I. And for red, it's going to be absolute value of h sub I minus r of I. And so all we have to do is take the absolute value of these. So you remove the minus sign. So the final step is to calculate the sum of these distances. For blue, it turns out to be a 10. For red, it turns out to be 8.5. So, what does this mean? We've now calculated the total distance that we've had to travel for the blue line to go from the blue line to each point, and for the red line to go from the red line to each point. And using golf scoring, the red line wins. The red line has less total distance to travel. So with this absolute error metric, we're going to say that the red line is the winner. It's better at predicting the past. Now, let's do another metric called the squared error. And this is the one that you'll actually see more frequently. The squared error is equal to, well, the square of the error. So it'll be h sub I minus b of I squared. For red, h sub I minus r of I squared. And we've already calculated the inside here. That's the error. So we just have to square this value. So for the first blue one, it's 1 squared, which is equal to 1. For the first red one, it is 0.5 squared, which is equal to 0.25. So here's the rest of these values. And let's find the sum of the squared error. So this is the total squared error for the blue line turns out to be 20. And the total squared error for the red line turns out to be 14.75. And again, golf scoring, the red line wins. We have a lower total squared error. So what's our summary here? Which prediction is better? So I'll go ahead and write out that the prediction from the red line is better because the total absolute error and the total squared error are smaller. So this is great. We've now said that the red line predicts the past better. So therefore, we will assume that it predicts the future better. And so my final conclusion is that June will sleep 7.5. That was our red line prediction. 7.5 hours on day 7. Thanks.